Although it's possible to do these things by hand, all the data tabulation and calculation, a lot of automated solutions exist to assist us in the analysis and interpretation of results of sensory evaluation. So oftentimes you're dealing with panelists that may number in the 30s, 50s, or hundreds. And each panelist would have anywhere from 1 to maybe more than 10 responses or maybe 40 responses. And you have to make sense of all of those things. Luckily, we have different software. Some of them are paid, some are free. So you have SPSS, which is used primarily for the social sciences but can also be used for sensory evaluation. You have Excel, and then there are some which are more or less dedicated to sensory science, like CompuSense. Of course, there are freeware alternatives to this one. So SPSS, for example, has a freeware alternative, PSPP. It has more limited functions but has a somewhat similar graphic user interface. Spreadsheets, of course, have free counterparts, and then there are also some software for sensory evaluation that you can use. On top of that, there are things that are available in the web which could do short calculations for you. Say you enter the data and it does an analysis of variance with post hoc test or any of the other non-parametric tests for multiple samples. So the key here is to know where to find them and how to use them. So as you may have seen in the previous videos, there are instances there wherein in the sensory evaluation booth you have either something like a desktop or a touchscreen interface. And in those cases, the data is automatically collected, much in the same way that data is collected when, say, you have a Google form of some sort. So the traditional sensory evaluation method typically uses pen and paper, and then data is entered manually into the computer or even manually tallied onto more paper. So of course the advantages of digitizing your sensory evaluation test would be the speed of receiving test results, and of course there is an interface between the data entry system and statistical analysis programs. You can easily import or export your files from one format to the other. And then there is a reduction in errors involved in data entry. So sometimes human error could play a part in accidentally spiking up the, let's say, rate of errant responses. For example, you forgot to punch in a 0 at the end, so you now have a tenfold difference in the intensity of a response. Or if it's a demographic entry, you forgot 10 on the annual income, and therefore you have made one person 90% poorer in terms of the demographic result. Investing in data entry and analysis systems, on the other hand, is not something that's always an advantage. So the non-techie part of the consumer world will be unfamiliar with the usage of such equipment. They can easily understand ticking a box or shading a circle, but if they don't even know how to use a mouse, so or a touchscreen for that matter, then they may not be able to use the interface properly, or it may even commit errors. And even if we said that one advantage is the lessening of human errors, we know, of course, that automating things could also automate certain errors. For example, even if you just made a um, wrong decision in inputting your or in making your questionnaire, then that error would propagate to everyone. Or if data is analyzed automatically without the removal of outliers or those people who may have erroneously put in their answers, then that would be um, a disaster. For example, if you're looking at the self-reported height and weight, and then you saw someone there with a weight of 5 kilograms instead of 50, then that would go into your calculation, even though it's next to impossible to have an 18-year-old or an adult with a weight of 5 kilograms. Lastly, computer programs may not be flexible enough to handle variation in experimental designs or requirements for specific types of scales. This means that you have to be the master over the data management or analysis systems, and you know how to use them and when to use manual mode, so to speak, when you are doing your data analysis. So by the way, these things are applicable not just in your sensory evaluation class, but in pretty much all your scientific um, researches. So we always need to know, first of all, based on the objective and the sensory evaluation test conducted, what type of data are we measuring? Are these countable information? Are these nominal information that you can bin, like how many respondents are male, how many are female? Are these ranking or ordinal information? Can you consider this scale as interval data? Is this ratio data, and so on? Can I use parametric or non-parametric tests? Do you understand how the experimental design affects how you would analyze your results, or as well as how you would interpret flaws, if any, in your results based on these information? Then there's also the presentation and organization of descriptive statistics. It's easy to churn out a mean, median, and mode, or even the means and standard deviations, but will you present this as pie charts, as bar graphs? Will you have radar charts superimposed on top of each other, or spider plots? So that is entirely up to the researcher, and the software can only suggest stuff, but the rest is, of course, up to you as a human being. And for inferential statistics, you you can have the results based on whether or not there are significance groupings based on the mean and standard deviation, but it's still up to the person to interpret what do these things mean, because in the case of significant differences, not all significant differences can be detected in real life, or rather, sorry, are relevant in real life. For example, a significant difference in acceptability scores of 6, which is like slightly, and 7, which is like moderately, may not always translate into being purchased more often. That perhaps maybe price is a stronger factor in the purchase of the person, or the packaging perhaps would play a bigger role in enticing people to purchase.